So students, so far we have discussed quantum mechanical model of atom. And from the model and Heisenberg's uncertainty principle as well, it was quite clear that we cannot find the exact location of an electron in an atom. But what we have to do is we have to locate an electron in an atom. So, to locate an electron in an atom around the nucleus, a set of three numbers is required. And those three numbers are known as the quantum numbers. Now, what are these? Quantum numbers describe the position of each electron. So, each electron in an atom is described by a set of three numbers that are known as the quantum numbers. These numbers indicate the probability of finding the electron in the space around the nucleus. So, what are these three quantum numbers? At first, we have principal quantum number denoted with small n. Then we have azimuthal quantum number denoted with L, and then we have magnetic quantum number denoted with ML or simply M. These are the three numbers that describe completely an electron in an atom. But there is one more quantum number which is known as spin quantum number, that is denoted with Ms or simply S. That describes the spin of an electron, whether the electron is rotating clockwise or anti-clockwise. So these are four quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number, that gives us complete detail about an electron present in an atom around the nucleus. Now we shall study these four quantum numbers one by one in our video ahead. But before moving ahead, you should pause the video and note down what is written on the board. Done with writing? Yes. Let's start ahead. At first we have principal quantum number, that is denoted with M. Principal quantum number describes the size of the shell in which the electron resides. Principal quantum number, that is N, it tells us about the main shell in an atom around the nucleus in which the electron resides. The value of N could be 1, 2, 3, 4 and so on. If the electron resides in the first shell, this implies that the value of N is 1. If the electron resides in the second shell, then the value of N is 2. And similarly, if the electron resides in the third shell, the value of N is 3. So it just tells us about the main energy shell. It just tells about the main energy shell in which an electron resides. Now we know that each energy shell, each energy shell is associated with a particular energy. Okay. Since each energy shell is associated with a particular energy, this means that the principal quantum number n along with the energy of the electron. It also describes about the energy of the electron. So, two things. One, the shell number, and second, the energy associated with the electron is described by the principal quantum number. And it can have values as 1, 2, 3, 4, 5, 6 and so on. Moving on to our second quantum number, that is azimuthal quantum number. Second, azimuthal quantum number denoted with small l. Azimuthal quantum number tells us about the subshell in which the electron resides. For example, if we have to locate a child in the school, what we should do? To locate a child in the school, what we must know? To locate him or her, we need her class, section, and then roll number. These three things are required to locate a child in the school. Like if someone is in class 10, section is son and roll number 2, we can easily locate a child. So in class there is a section divided and inside section there are roll numbers. In a very similar manner, when we have to locate an electron, we must know the main shell, which is given by principal quantum number n, and within that main shell there are subshells. Within that main shell there are subshells. That subshells are given by our second quantum number, that is the azimuthal quantum number, and it is denoted with a letter L. This azimuthal quantum number can have values from 0 to n minus 1. L can have values from 0 to n minus 1. For example, if we have n is equals to 1, which means for the first shell. For the first shell, the value of n is 1. Now we have to talk about its subshell. The value of n, the value of L will be 0 to n minus 1. From 0, 1 minus 1 is 0. L can have only one value, that is 0. If the value of n is 2, which means that we are talking about second shell. If we are talking about second shell, L can again have two values from 0 to n minus 1, right? And the value of n here is 2, n minus 1, which is 2 minus 1. It will be from 0 to 1. This implies L can have two values. L can have the value 0 or it can have the value 1. L has two values. L is equals to 0 and L is equals to 1 because we have two shells out there. And in a very similar manner, if we are talking about n equals to 3, that is the third shell. What will be the value of L then? From 0 to n minus 1, that is 3 minus 1, from 0 to 2. It can have values as 0, 1 and 2. So this is how we locate subshells in a shell. Now as per these values 0, 1, 2, we can have different values of L, right? Value of L and its designation. L can have value 0, 1, 2. Similarly, it can have 3 value as well. So for the value 0, its designation is S. For 1 we use P, for 2 we use D, and for 3 we use F. Designations are given. 0, the value of L is 0, means it is the S subshell. It is the S subshell. The value of L is 1. It implies it is P subshell. The value of L is 2. It means we are talking about D subshell, and in a very similar manner, if we are saying that the value of L is 3, this means that we are talking about F subshell. So this must be very clear. 0 means S, 1 means P, 2 means D, and 3 means F. So after the main shell, subshell can be predicted by using a second quantum number, that is the azimuthal quantum number. Now moving ahead about the third quantum number. And what was it? Yes, I have already told you. Okay. The third quantum number is magnetic quantum number. It describes the orbital. It describes the orbital in which the electron resides. Orbital means the space around the nucleus where the probability of finding the electron is max. Where the probability of finding the electron is maximum, that orbital is described by the magnetic quantum number. Actually, what happens is Earth has its own magnetic field, and electron also behaves like a tiny magnet. When the magnetic field of an electron interacts with the magnetic field of the Earth, those electrons just orient themselves into certain specified regions. Those certain specified regions are the orbitals. And these orbitals are predicted by the third quantum number, that is the magnetic quantum number denoted with ML or simply. The value of magnetic quantum number varies as minus L to 0 to plus L, which means that if the value of L is 0, this implies ML is also equals to 0. If the value of L is equals to 1, this implies ML would have integer values such as on the number line. 0 in the middle, then we are saying that L is equals to 1. Integers would be minus 1 and plus 1. So the values of ML are going to be minus 1, 0 and plus 1. In a very similar manner, if the value of L is equals to 2, this means that the value of ML will be on the number line again from minus 2 to plus 2. We have 5 values as minus 2, minus 1, 0, plus 1 and plus 2. So, in the L subshell, L is telling about subshell and ML is telling us about the orbital. Okay. In L subshell, there is only one orbital. There is only one orbital, which is the S orbit. Because we have done 0, 1, 2. If the value of L is 0, 1 or 2, then its designation is S, P and D. Okay. When we say L is equals to 1, for L is equals to 1, we are talking about the P subshell. And in P subshell, there are 3 orbitals. How many orbitals are there? There are 3 orbitals, namely Px, Py and Pz. And we are talking about L is equals to 2. That is, we are talking about D subshell. In D subshell, there are 5 orbitals. There are 5 orbitals named as dxy, dyz, dzx, dx square minus y square and dz. So our third quantum number, which is the magnetic quantum number, tells us about the orbital, that is the space around the nucleus where the probability of finding the electron is maximum, and its value varies as from minus L to 0 to plus L. For S subshell, there is only one orbital, S orbital. For L subshell, L equals to 1. That is, the P subshell, there are 3 orbitals, Px, Py and Pz, and for L equals to 2, that is D subshell, there are 5 orbitals, dxy, dyz, dzx, dx square minus y square and dz square. This quantum number also describes the shape of the orbital in which the electron resides. It also tells us about the shape. For example, when we say s orbital, s orbitals are symmetrically spherical and the probability of finding the electron is maximum around the nucleus, and as we tend to move away from the nucleus, the probability of finding the electron also decreases. So the electron density would be maximum somewhere around the nucleus. And when we say P subshell, there are 3 orbitals, Px, Py and Pz, and their shapes along the axis. 3 axes we have. If we talk about the 3-dimensional space, x-axis, y-axis and z-axis. X, Y, Z, X, Y, Z. So, it is in the form of lobes. For Px, lobe along the x-axis. For Py, the shape is like this. And for Z, along the z-axis, it is Pz. So, at first, you all should note down the shapes for s and p orbitals, and then we shall move for our d orbital. I hope you'll be done with the noting. Yes, moving ahead. When we have d orbitals, dxy, dyz, dzx, dx square minus y square, and dz. These three orbitals dxy, dyz, and dzx are similar in shape. Okay. For the dxy, you need to mention the two axes, x and y. For dyz, we will mention two axes, yz, and for dzx, we will mention z axis and x axis. Now you have to make lobes in between the axes. For dxy, it is like a lobe here and the lobe here, and then mark the electron density. And similarly for dyz and dzx. For dx square minus y square, we need the two axes, x and y, but now we'll be making the lobes on the axis. These were the lobes in between the axis. Now we will be marking the lobes on the axis. For dx square minus y square. And for dz square, we need z axis only. And now we will mark the lobe over the z axis, and there is a ring around it. We have to mark the ring as well, and this is the z axis. So these are the shapes of the 5 orbitals, 5d orbitals, that is dxy, dyz, dzx, dx square minus y square, and dz square. Now talking about our last quantum number, that is the spin quantum number. Denoted with ms. It tells about the direction in which electron is spinning on its own axis. S can have two values, plus half or minus half. Plus half means the electron is spinning in the clockwise manner. S equals to minus half means it is spinning in an anti-clockwise manner. Clockwise is also represented by an upward arrow and anti-clockwise as a downward arrow. So the spin of the electron is described by the spin quantum number. Hence, by using these 4 quantum numbers, principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number, we can easily locate an electron in an atom. So that was all for today's video. Now we will meet in our next video, but before signing out, do like the video and share with your friends, and please subscribe our channel if you have not subscribed yet.